Question 2b. Use Pascal's triangle to do this expansion here. So let's say question 2b. The question to be done is 1 over x minus the root of x to the power 5. So, you know, when they say Pascal's triangle gives us the coefficients only. So we understand the powers relationship. So we know the Pascal's triangle sits like that. The first one is power 0, and then power 1, and then power 2, and then power 3, and then power 4, and then power 5. So these are the coefficients of what you're looking for, of the expansion that you're looking for. So we have 1, 2, 3, 4, 5, 6 of them. So we start. So I'll do it from here, 1 over x minus the root of x to the power 5 is equal to, the first coefficient is 1. So I'm multiplying this to the power 5, and then plus the second coefficient is 5, multiplied by 1 over x to the power 5 minus 1, which is 4. And then now I bring in the b part, root x plus 10, that coefficient, 1 over x to the power 3, and then the negative root x to the power 2, and then plus 10 again, 1 over x to the power 2, negative root x to the power 3, and then plus 5, 1 over x to the power 1, and the negative root x to the power 4. And then the last one is 1, and it is the coefficient of b to the power 5. So you simplify. So this is just 1 over x power 5 minus 5. 1 over x power 4. And then the other one, that x half there. That x, that with x, if you want, you could write it as x to the power half. That is, if your idea is to combine the x is that we are seeing there. But then the question did not even ask much. So maybe there will be no need to do that. I'll just put the root of x there. And then the next one, I know when it is squared, I'll just get the x alone. So maybe this time around, I'll just say 1 over x squared. Of course, because it has been, I have x3, and then with x squared, it's just x, so x over x3, that becomes x squared. And then the other one, I'll have minus 10, and then x, the root x, divided by x squared. So what does this do? To take away the x that is up here, and then reduce the power to just 1, and then plus 5 now, and then the root of x to the power 4, that is like x squared, and then x into x squared. Now we have x up, and then minus x squared root x, because I know that the root of x to the power 5 is like root x power 4, and then root x. The root x power 4 is x squared, and then root x. So that's why here I've written this thing there. and then minus because the power is odd. So that's how we get those terms. I think it doesn't matter really if you need to put them together, looking at the power there. So we just leave them like that. And then go to question 3. So this was just Pascal's triangle. I think the highest they can give you in Pascal, maybe 6. Yeah, but 5 I think is another. That would be, go to question 3. Question 3a. Simplify 5 factorial multiplied by 4 factorial and divide by 6 factorial. This plus 8 factorial multiplied by 3 factorial and then divide by 7 factorial. So understanding the factorials is also a very good thing. So when you're having factorials, you look at which side has a bigger one. So like for the first one, 6 is bigger than both numbers up 5 and 4. So we go to 6 as we fix the 5. So seeing that between those two numbers up, 5 is bigger than the other. So we fix the bigger one and then expand the 4. 4 times 3 times 2 times 1 over, then expand the down one, 6, just up to 5 factorial. So that's this 5 factorial and this one, they can cancel each other because they have the same value. And then these 3 and these 2, they can give us a 6, which will take away this one. And then plus, now for the other one, 8 and 3, we see that 8 is bigger than 7. So what we do is we expand 8 up to 7 factorial, and then expand 3 up to 1, and then divide by 7 factorial. Because we know this 7 factorial and this one have the same value, those will cancel, and then we get 4 this side, multiplied by 1s, which is just 4, plus, we expand the other side, so we have 3 times 2, that is 6, times 8, that is 48. And then adding this to, we get 52. That's the number which was asked here. Well, they're saying express the answer without factorials. Well, we don't have factorials there. We go to B, find, if possible, the constant term in the expansion of x to the power 1 over 4, and then minus 3 over x to the power 1 over 2. This is everything to the power 8. So to do that, to look for a constant term, well, you may not have to expand up to 9 tenths. Maybe that is too much. You may just put things together using this formula. That if n will be put there, and then r here, and then a n minus r, and then b r. N is always the power, so you're looking at it as a plus b to the power n as we pick those. So n is 8 in this case, and r is unknown because we don't know the term position. And then a is x to the power 1 over 4. Well, this is the power 8 minus r. And then b is negative 3 over x to the power half, and then to the power r. The task that we have here is to extract the x's and put them together so that we can start talking about the meaning of independent, the meaning of a constant term. So we first get this -3 here. We get it away from x, so put it here, -3 to the power r. Then because x is in the denominator, it can be written as x to the power -half. So that when that happens to the power r, the next thing is going to be x to the power -half r. So we put those x. As we expand here, 1/4 times 8. So 1/4, we're expanding 8 minus r. That is 2 minus 1/4 r. So we get 2 minus 1/4 r. And because we are dealing the same base x, so we just add the powers. Now, the question is asking for a constant term. For a term to be constant, it means the power of x in that constant term is 0. So you pick this power of x, the 2 minus 1/4 r minus 1/2 r, and equate it to 0. So you can multiply throughout by 4. If you multiply throughout by 4, we are trying to avoid the fractions. So I'm going to have 8 minus 2r. 8 minus r, because that 4 will take away this 4. So 8 minus r, and then 2 into 4, we get 2. So this will be 2r is equal to 0. So we get 8 is equal to 3r, divide by 3, divide by 3. So it has turned out that r is equal to 8/3. So you say, well, since r is equal to 8/3, there is no term, there is no constant term. There is no constant term in the expansion. So because that is the case, it means that we want of a term that is going to be a constant term. All the terms will have the variable x. That's what this is telling us. If it was a whole number like 2 or 3, then it means you have a term. Now we don't have a term. Remember, 8/3 is not constant. Is not a whole number. It's some decimal number. Okay. Then we go to question 4. Evaluate each of the following limits. A, the limit as x goes to 2, if you are given x to the power 3 minus 8 over x minus 2. Now, if you try to substitute 2 there, you're going to have 2 to the power 3 minus 8 over 2 minus 2. This is like 0/0. This situation is undefined. So then what do you do? Well, you have two options. The first option, okay, is to use your what does do. So what does this do? Well, this one will tell you that for you to get this limit, you need to actually differentiate the numerator, okay, and again differentiate the denominator, meaning don't use quotient rule, just differentiate them one by one. So this will give us a limit as x goes to 2. When you differentiate x to the power 3 using power rule, you get 3x squared. When you differentiate 8, you get 0. When you differentiate x, you get 1. When you differentiate 2, you get 0. And then in the remaining one now, where there is x, substitute 2. So it will be squared. This is going to give us 3 by 4, which is 12. Very correct. The second option is where you use long division. Is where you use factorization, I mean. Where you use factorization via synthetic division. So what you do is you have the limit as x goes to 2, and then x3 minus 8. We've already seen that 2 is making it 0, meaning that 2 is a factor. And then pick the coefficient because the numerator there is a polynomial of this kind, plus 0x minus 8. So pick the coefficients 1, 0, 0, negative 8. And then the first number, you add a 0, it comes down. And then multiply 2 times 1, you get 2. Add, you get 2. Then 2 times 2, you get 4. Add, you have 4. Then 2 times 4, you get 8. And you have 0. So these are giving us the product that we put up here, x minus 2. These 2 that we have used here, if we use it as a positive, here it will attract a minus. Multiplied by this quadratic here. Remember the synthetic is still giving us a coefficient, but now of the lower power. So we have x squared, and then plus 2x plus 4. Everything divided by x minus 2. So now this and this will cancel. And for the sake of the limit, we now substitute where there's x. We take 2. So we have 2 squared plus 2 multiplied by 2 plus 4. And this is 4 plus 4 plus 4, which is equal to 12. So we usually get to it like that. Okay. It should be nice. So you pick n that you feel may work well for you. This is A. Let's go to B. B, the first one is the limit as x goes to 0 from left of 2x squared plus x over the absolute value of x. So here you can't substitute x is equal to 0. It will become very undefined. And again, differentiating is a bit tricky if you're not careful with the absolute value. So what to do is we'll redefine this function. Remember, the absolute value is defined as positive x if x is greater or equal to 0. This means we're moving from the right. And then defined as negative x if x is less than 0, meaning they're moving from the left. So when they say 0 minus, we mean from the left direction. So for the denominator, it will pick this function. So we have this is equal to the limit as x goes to 0 from left of the numerator is maintained over the denominator has now become negative x. Okay, because the absolute value is defined in those two pieces. So if you're talking about the left direction, then you pick the one that is minus. So this is giving us the limit as x goes to 0 from left is 2. You can now divide 2x squared divided by negative x. We get negative 2x. And then positive x divided by negative x, we get minus 1. Then substitute the value of x there. That is 0 minus 1. So I've gotten negative 1 as the answer for the first one. For the second one, we are told the limit as x goes to 0 from right of 2x squared plus x over the absolute value of x. So again, you get back here, when they say from right, the absolute value becomes positive x just. So we have the limit as x equals to 0 from right of 2x squared plus x over x. And then divide there, we get the limit as x equals to 0 from right. X into 2x squared is going to give us 2x plus x into x, we get 1. And then substitute where there's x, you put 0 plus 1. This will give us 1. Here they can ask you, does the limit exist as x? Find the limit as x goes to 0 of this function now. They stop talking about the sides. They just ask you to find the limit. So you say this limit does not exist. It does not exist because the limit is only existing if when you get from left, you get the same number as from right. So we needed this one to be equal to this. Then we would have said the limit exists. And then they ask, is f of x equal to 2x squared plus x over the absolute value of x continuous at x is equal to 0? So the answer is no, because the limit does not exist. The limit does not exist like that. Okay, so the last one, C, sketch the graph of the following function and determine if it is continuous at the given point. C, f of x is equal to 2x plus 1 if x is less or equal to 1. The same function is negative x plus 4 if x is greater than 1. And that is happening at x is equal to 1. I want us to check for continuity at x is equal to 1 after we've sketched. So first we sketch. So we have the number 1 as the boundary number for the two pieces of this function. So you pick 1 and substitute in the top function and say what is f1 there. We get 2 by 1 plus 1, which is 3. So we get a 3 here. And we close because it is less or equal to. So it is part of that family. And then because we are talking of less or equal to, I would also pick 0 because 0 is less than 1. Substitute in the function. What is f of 0? That is 2 by 0 plus 1, giving us 1. So this is crossing the straight line, crossing at 1. Or you can also know this other side by equating 2x plus 1 to 0. That is going to tell us that x is minus 1 over 2 actually. So you put minus 1 over 2. Then you go the other side. Pick this one again, substitute it in this function. Well, it's 2 part of f as well. So this is giving us -1 plus 4, which is equal to 3. So though we are supposed to open, but lucky enough, other function closed it, so you can't open what has been closed. Please don't put another circle like that. No, you make your graph wrong. So just leave it like that. And then pick a number bigger than 1, say 2. So what is f of 2? F of 2 is -2 plus 4, which is equal to 2. So we're getting 2 somewhere there, telling us that that is a line that is going to come like that. And then we can know this value by equating -x plus 4 to 0. So it's going to be -x is equal to -4 divided by -x by -1. So x is equal to +4. So we get a +4. So we have sketched the function. Is there need to label the lines? No, there's no need. Okay. Then now we answer the question of continuity. For a function to be continuous, okay, for f to be continuous, we need one, f of c must be defined. That is 1. And then 2, the limit as x goes to c of f of x should exist. And then 3, that this limit that exists, should be equal to the value that we got in part 1 of f of c. So we start checking what is f of 1. We substitute 1 where it is included. So we have 2 multiplied by 1 plus 1. This is 2 plus 1, which is equal to 3. And then part 2, we get the limit as x goes to 1. Now, because we have 2 functions, we start by x goes to 1 from left, meaning you go to the less or equal to. So you get 2x plus 1. This one will give us 3. And then you get the limit as x goes to 1 from right. You now get the 1 from greater minus x plus 4. Again, this is -1 plus 4, giving us 3. So because the 2 are equal, then we say the limit as x goes to 1 of the whole function f of x is actually equal to 3. And lucky enough, this is the same way that we got as f of 1. Hence, f of x is continuous. At x is equal to 1, like that. And that's where this sample ends. And the sample here means a lot. This is live. So whatever I'm going to write is like a deferred paper of this one. That's the meaning. So meaning that your the actual quiz is going to have the same content as the sample. So please take care of this solution and make sure that you understand. Then train yourself to race against time. This is 1 hour 16 to 17 that you may not manage to finish if you are slow. So try to find better ways of racing against time so that you're not always disadvantaged there. And I wish you the best. Don't have a good day.